If we have a technology that is decoupling you from fossil fuel use, it's allowing you to sequester a portion of your emissions and use local materials instead of having to import stuff from Indonesia or China or India or Turkey. To us, that is a very compelling value proposition.
Hey there. Welcome to The Climate Cycle, a podcast focused on Canada's climate tech ecosystem. In each episode, we sit down with founders building climate solutions right here in Canada to better understand the challenges presented by climate change and what we can do about it. Today, we're talking about cement, carbon, and Canada's industrial future with Apoorv Sinha, co-founder and CEO of Carbon Upcycling. Concrete is really one of the key building blocks of modern life. It's in the foundation of your house, in sidewalks, in high-rise buildings, all kinds of things that we really take for granted. In fact, the only material that we use more than concrete is water. But behind every slab of concrete is cement, the critical glue that holds it all together. And making that cement has a serious climate cost. Most cement is made by crushing up limestone and heating it to extremely high temperatures, a process that requires a huge amount of energy and releases nearly a ton of CO2 for every ton of cement that's produced. Cement production alone is responsible for almost 8% of global emissions. But what if we could flip that story and actually turn cement into a way to draw down CO2 and lock it away permanently? That's exactly what Apoorv and Carbon Upcycling are doing. They're creating a clean substitute for traditional cement by taking waste materials from mining and industry and reacting them with CO2 to permanently lock away carbon. And crucially, they can do it in a way that fits right into existing cement plants while helping localize supply chains that are becoming increasingly precarious. In our conversation, we talk about how carbon upcycling is helping cement producers cut emissions and costs, what it takes to land partnerships with global cement giants like CRH and Titan, the role of government procurement, financing, and policy in scaling climate tech, and the opportunity for Canada to build major infrastructure projects while cutting carbon pollution and rebuilding local manufacturing. And now, my conversation with Apoorv. Apoorv, good to have you on the show.
Thank you, Justin. Good to be here.
Yeah, I'm really glad we got a chance to sit down. I'd love to actually kick things off with a bit about your story. So I'd love to hear, what was your path to starting Carbon Upcycling? You started this company back in 2014 when climate tech really wasn't a thing yet.
Yeah, it's a fair point, Justin. And I would say in a bizarre way, like within a year or two of starting Carbon Upcycling, climate did become a thing and arguably is less of a thing today than it was back in 2016 or 17.
Right.
But yeah, just to give you a quick overview of myself, my name's Apoorv, as you mentioned. I grew up in the Middle East. I'm from India originally and have always been, I guess, exposed to the energy industry and just chemistry for a long period of time. My dad worked his entire career in conventional energy, and growing up in the Middle East, especially in Kuwait, which tends to be a very oil and gas intensive economy, was always exposed to kind of how energy can change not just the economy of a country, but also, the society and the geopolitics of a region. And so being exposed to that was great. I did my undergrad in Atlanta. So I moved to the US for my undergrad, did my chemical engineering degree there, and always was more interested in process chemistry and chemical engineering than I ever was in, some of the stuff around computers and digital kind of work. And yeah, have now been in Canada for just under 15 years, 14 and a bit. And as you rightfully said, founded Carbon Upcycling pretty quickly after moving to Calgary. And so that's been a journey in and of itself. And it's pretty exciting to see kind of the progress that we've made, but I'd say by and large, way more excited about the future than about kind of looking back at the past and what's happened over an eventful decade.
Yeah, absolutely. It's a really interesting trajectory you've had, coming from oil and gas and working in the Middle East. And I guess now kind of in Alberta, the heart of oil and gas country in Canada as well. So it's an interesting kind of like tie through all of this. And so now you've started Carbon Upcycling. Can you talk about what carbon upcycling does and kind of the problem that it's solving?
Carbon Upcycling, when we founded in 2014, was very much about one mission, which was how do we take carbon emissions from industrial plants, industrial processes, and make it into a valuable product. What we've evolved into over the last 9 to 10 years, Justin, is a technology that's also able to do this waste upcycling with solid waste materials. So we really see ourselves as much as a circularity play as we do a carbon play. And what I mean by this really is, the technology in its current form with what we're doing in the building material sector, which is our main target market, is we're taking solid wastes coming from a range of different industries. We're primarily focused on a coal ash that is left behind by legacy coal power plants. We're focused on steel slags. So as you're making types of steel that are produced with electrical furnaces, like electric arc furnaces or basic oxidation furnaces, the chemistry of these steel slags is inherently different than the type of slags that have been used in the building materials sector thus far. And so that's another waste stream, or a low value stream, I should say, that we see a lot of value in upcycling. And then lastly, we're focused on mineral tailings. So mining operations, even as we decarbonize the energy sector and transportation, there's a bigger and bigger focus every year on how do we get more copper, more nickel, more lithium, and other materials into the world. And even with these aggressive recycling methods that we're starting to look at, there's still going to be a lot of virgin resource extraction that's going to happen over the next 50 years. And so what we're focused on is how do we help these type of companies take the byproducts of these mining operations, essentially mine tailings, and activate them to then create a building material. And where this whole story kind of comes together is when you're talking about feedstocks of these types, like whether they be slags or ashes or mine tailings, these are materials that are actually produced in volumes that are not that far off from cement production around the world. And just for your listeners, cement produces about 8% of global emissions, 7 to 8% of global emissions a year. We make 4 billion tons of cement every year across the world. And all of this is generally centralized in the 26 to 2,700 cement plants that actually do the production of the cement. And then this goes out to concrete facilities like ready mix or precast plants. And so our view is that if we can give these cement producers locally sourced, low value materials that they can use as feedstocks, we provide a very compelling solution that can be globally relevant. And of course, looking at it as a Canadian headquartered company, we believe can add a lot of value to the Canadian economy as well.
Yeah, that's fascinating. You're really looking at two massive spaces, like mine tailings. The amount of mine tailings and just like rock that's processed every year is astronomical. And then concrete, like from what I saw, it's the only product that we use more of is water, which really speaks to like the scale of concrete use around the world. Maybe we could zoom in a little bit first on the technology as it is today and kind of how you're turning those waste products into this, useful material for building materials.
Absolutely. I think maybe just to set the context, it is really important to recognize that building materials and producing them in a low carbon way or in a way that actually sequesters carbon is by no means a new idea. A lot of people talk about how Facebook wasn't like the first social networking app, right? Or Google wasn't the first search engine. I mean, in a bizarre way, the approach that we're taking in low carbon building materials by no means is the very first of its kind. Really what we focused on is a tweak that we believe makes it more practical. And so with Carbon Upcycling's core process, we focused on a dry mineralization technology. And essentially what that means is if you look at a lot of the carbon sequestration or CO2 related kind of processes that are out in the space, they've all focused on wet chemistry. And that means that you need a lot of water use. And generally, if you look at kind of how the supply chain for the building material sector is set up, everything that happens at those 2,600 odd cement plants in the world, that is all dry chemistry. When you make cement, you're usually using a high temperature oven, a kiln, to bake the limestone and to release the CO2 and leave behind the calcium oxide that you need to make what we call ordinary Portland cement, or in normal language, we just call that cement. And so that cement involves high temperature processes. It involves the handling of different kind of SOx and NOx emissions, CO2 emissions, and obviously dealing with a lot of different kind of process handling equipment. But none of those pieces of equipment ever expose the cement to, water. And primarily that's because as soon as the water hits the cement, it begins to react and it starts to set up and actually do all the things that we like it to do. But frankly, if it does that at a cement plant, that's a good thing happening at a bad time. So all of the wet chemistry stuff that I would say the last 30 to 40 years of carbonation chemistry has been focused on has always been downstream of the cement plant, like at a ready mix plant, a precast plant. because that's actually the part of the supply chain where the cement begins to see the water. What carbon upcycling started looking at about 5 years ago, so in the first 5 years of our company's existence, we weren't really focused on cement at all. We were looking at nanochemistry for polymers, for energy storage. And after a couple of pivots, we realized that our technology is actually very well suited to take these industrial byproducts like slags and mine tailings and convert them into these ingredients to make low carbon building materials or cementitious products. And the real kind of novelty, I suppose, in what we did was we said, we're going to deal with a solid gas chemistry, not a solid liquid chemistry. And so we have been working a lot on how do we optimize our processes so that the CO2 that's in the gas that leaves, the stack of a cement plant, that gas already has some relative humidity in the gas. So it's not as if it's bone dry. You've got some relative humidity or moisture that you can use from within. And then by optimizing our reactor design, doing a lot of fundamental chemistry work on the kinetics of carbonation, and more recently on the chemistry of mechanochemical activation for materials that do not have that much CO2 uptake potential, what we've essentially realized, Justin, is that we can come up with a dry process that can be bolted onto a cement plant, still keep them away from water, and allow them to create a product that can be shipped and moved and handled exactly like the conventional cement that they've been selling.
Gotcha. Okay. So there's that piece there where you need to kind of fit the profile of the cement manufacturers. We're like, we don't want water anywhere around this. We need a dry process. But then the process itself, it sounds like, so you're taking, let's say, slag and mine tailings, which is, I would imagine, looks kind of like powder or rock, and then breaking that up and injecting CO2 into it. And is that kind of how the process works? Maybe you can just talk about like that stage of it and how that kind of comes together.
Yeah, no, I mean, you're like 80% there already. So
Okay.
Exactly. I think so there were two fundamental processes that can either happen in discrete steps or they can happen at the same time. So one of them is a physical activation. These materials have to be physically ground to a certain size and have to have a specific type of surface texture so that they can actually start reacting with CO2, which is the second step, which is the carbonation step. And so in those cases, like the plant that we're building in Mississauga with one of our partners, CRH, we have a physical grinding step and then we have a carbonation step. And these are the two main steps that actually allow you to create an activated cementitious material. In other cases, we can actually, because the CO2 doesn't actually get absorbed in the matrix of the material. This would be like, for example, some of the clay in Ontario that gets dredged up as you do construction projects. So if you excavate for a foundation of a high-rise building, you're taking away a lot of soil. The heavy majority of that soil is clay, and that clay is usually a 2-to-1 clay. It's a clay that's very rich in chloride. It's a 2-to-1 clay because it has 2 times as much silica as it does alumina, which is probably a bit too geeky for most of your listeners, but it does have interesting consequences in terms of how that material can actually become a cementitious product. And thus far, Justin, no one's been looking at those type of clays to make cement or to make a cementitious add-on. But what we have found over the last couple of years is that those kind of materials can also go through this grinding and CO2 exposure step, and we can actually combine them and kind of do that all in one go, where instead of the CO2 becoming part of the matrix of the clay, it actually helps leach the clay and almost has a chemical texturing effect that allows the clay to become more reactive and have a lower carbon footprint because it ends up becoming, a pretty good cementitious material. In each of these cases, the chemical process design can look a little bit different, whether you process a pozzolan, a clay, a mine tailing, or a slag. But generally, the fundamental steps of you get this fine powder, you got to grind that down to a certain size, you then have to expose it to a reactor where you're able to activate it in the right way. And activation can either mean activation to capture CO2 when the chemistry is right, or it can solely mean activation in terms of making it a cementitious product that gives you strength and allows you to make a low carbon cement.
Okay, that makes a lot of sense. So where does that material then get used? Like this goes then to, I would imagine, concrete manufacturers. Love to understand like how this actually gets used and that low carbon aspect. You talked about that. Obviously, if you're storing carbon and it's mineralizing and getting locked away, I can see a kind of carbon savings there. But also with the clay aspect of it, I'd love to maybe understand a little bit more about how does that kind of result in low carbon concrete?
Yeah, it's an excellent question. And going back to the comment you made a few minutes ago about how much concrete we use. So just to maybe start with that, for every cubic meter of concrete that we use, and concrete could be in your home foundation, it could be in a sidewalk, it could be, literally on the floor of a mall that's trying to renovate or whatnot. But every cubic meter of volume of that concrete probably has about 150 to 300 kilos of cement. And that
Okay.
cement is the dry powder that is leaving from the kind of factories that we're trying to plug our technology into. So to now work forwards from that cement plant to make that 300 kilos of cement is having to take limestone from a quarry, and they have other chemicals that they mix into it as well, but the heavy majority of it is limestone. And that calcium carbonate is the limestone quarry that they excavate, they crush it up, and then they put it through this oven, the kiln, at 1200 to 1400 degrees C temperature. And that is where all of the emissions come in. So there's emissions because you have to heat stuff to that temperature. Whatever fossil fuel you burn, generally it's a natural gas or coal fuel, that has its own emissions. And that's about a third of the emissions from making this product. 2/3 of the emission actually come from the fact that you're taking calcium carbonate and decomposing it. And when you do that to make calcium oxide, which is the bulk of your cement, the other 44% of what you've made is CO2, which goes directly into the atmosphere. So if you put, for example, 1 ton of limestone through a kiln, about 400 kilos of that will become CO2 and just go out. So that ends up being the heavy majority of your emissions. So how does carbon upcycling support that view is by shrinking or reducing the amount of limestone-based product you have in your cement. So, if that 300 kilos of cement is all limestone-based material, as you can imagine, that'll have a pretty high carbon footprint. But if, let's say, 150 or 100 kilos out of that 300 kilos is actually coming from a material like slag, let's say, that is actually sequestering carbon and actually emitting no carbon at all because it's all electric, now all of a sudden you've reduced the emission of that 1 cubic meter of sidewalk from, let's say, 200 kilos of CO2 to maybe 120 kilos or 100 kilos of CO2. And so it is a partial kind of reduction. And ultimately, our view is that the near-term change that's going to happen in heavy industry, whether it be steel or cement or aviation or marine transport, all of this is going to happen through incremental steps towards net zero. Like that is a fundamental thesis that we've always believed in. And our view is this is the most cost competitive and collaborative way to get new solutions into the market. And so sticking to that, if we can reduce the clinker factor of that cement by 20% or 30 or 40, over time, every extra percentage of this limestone-based clinker that we replace with our material at the cement plant means that the rest of the supply chain can basically use this low carbon material almost by default. And so they don't have to change anything about what they do because all of that change is happening at this hub where the cement plant has committed to making the change.
I see. Okay. And maybe just to put a fine point on this. So there's cement and there's concrete, right? And like cement is kind of the glue, and then concrete is the glue plus aggregate kind of mixed together to make the final product. So are you working more with the cement stage and those producers? Are you working at the concrete production? Or maybe I've misunderstood that. Maybe you can just kind of talk about like that distinction.
Yeah, no, firstly, Justin, I think you had that exactly right. And I would say from an operational perspective, we're working with the cement plant specifically because that's the hub. So like a general cement plant will make 1 million to 2 million tons of cement a year, right? So a pretty large amount. However, a concrete plant will only maybe use, let's say, 50,000 tons of cement in a whole year, or 100,000 tons, because they tend to come in various shapes and sizes. And so we think of it as like a hub and spoke model where every cement plant will usually serve 50 to 100 clients in their region. And so it's much more cost efficient and frankly, resource efficient from an engineering perspective as well, if you can just kind of focus on the hub and get your technology plugged in at scale there. And so from a practical standpoint, you're exactly right. We're focused on the cement side, not the concrete. Now, having said that, one of the things that we're very keen on in terms of the partnerships that we seek is we want to work in places where, at least for the time being, like I would say between now and 2030, we'll very much be focusing on geographies where our partners have a vertically integrated presence. Because ultimately, as you can imagine, let's go back to that sidewalk where you're pouring, some low carbon concrete with carbon upcycling. if there's an issue at that project, and even if that stemmed from something that went wrong or whatever at the cement plant, the contractor, the precaster, or let's say the ready mix company in that instance, and the procurement person, like everything that comes downstream of the cement plant needs to be able to trace back the issue or the challenge right to where this happened. And if all of that is vertically integrated and owned by the same company, that makes the transfer of information and the knowledge transfer a lot easier and smoother. And definitely with some of the projects that we'll hopefully touch on during this conversation, I'll tell you that that's been one of our key criteria that we focused on with our partners, because at this stage it is so important for us as a company and as a technology provider to have a very good level of understanding that literally the contracted hourly wage worker that is like maybe working on finishing the concrete can give us the information at the plant level where maybe we have 2 or 3 operators, and that person, even if he's only going to do one job on a carbon upcycling project in the next year, we want him to be able to somehow relay what he's learned over to our guys at the cement plant, maybe 100 kilometers away. And that just becomes really challenging in such a fragmented industry.
Absolutely. That's a really interesting setup, because I've heard it from the perspective of actually more on the adoption side, that having that fragmented chain, getting each level to buy into opting for a low carbon product can be really difficult. So that makes a ton of sense on the vertically integrated, but the learning aspect is really interesting too, where you don't have this kind of black box at a certain point where, okay, what's actually happening in the field, we can't learn from it. So if you're vertically integrated, that makes so much sense where you actually understand, hey, we're hearing this in the field about here's what it's actually like to work with the material. I would love to talk a little bit about the carbon landscape here. So we have things like carbon capture and storage, which typically, takes carbon from an industrial process and stores it underground. And there's some mineralization that happens there. In the utilization space, we have folks that are capturing carbon and turning it into like chemicals and fuels and other things. And then there's a few people working in this kind of concrete building materials space. You've touched on a little bit, but I'd love to understand, how do you differentiate yourself from some of those competitors in that landscape? And we can focus in on kind of the concrete and building materials space, if that's helpful.
Yeah, I think we could probably spend 2.5 hours if we wanted to cover the gamut of the space here. But I would say specifically within kind of the sandbox that we play in, Justin, I would say number one, the fact that we can integrate at these cement plants because of that dry versus wet chemistry piece that I was talking about. I think that's a fundamental differentiator that we continue to focus on every single day with our partners. And frankly, the list of opportunities or projects that we're considering at the moment are all kind of predicated on the unique value proposition that provides you from an integration standpoint. Because, as I mentioned, if you have a technology that needs you to work with wet chemistry, you're almost by design forced to work at those spokes instead of the hub. And so that's an important point. Another big technical point of, I guess, uniqueness, I wouldn't necessarily say competitive edge, because I genuinely believe that, out of the so many different companies that are out there working on decarbonizing cement, every single one of them could be extremely successful in solving even a particular niche for the market. And all of us can still do that without needing to kind of stomp on each other's feet. So I do genuinely not look at this from a competitive standpoint, but more so from the perspective of how do we convince our customers that we've got something that they should pay attention to. And so within that context, the fact that we can take CO2, sequester it, which not many companies can do that with industrial grade CO2, not requiring 90% purity CO2. So most of these cement plants will usually have carbon emissions of 10%, 15, maybe 20% CO2 by volume in their CO2 stack. In all of our designs, including the projects that we're looking at right now, that is enough. That is pure enough, and you don't have to do a capital or an operating expense outlay to make that work. And I think that's another big point that has helped us enable some of these projects to move forward. And the last thing I'll say, Justin, which in a sense kind of ties all of this together in, ultimately what a lot of these private for-profit companies care about, and rightfully so, frankly, is they want to make sure that whatever technology they adopt is able to be cost effective, give them a competitive edge in their local markets, but also do that without hurting their margins. And in fact, actually give them a strategic edge to expand margins over time. And so that to us has been another big part of just generally how we've looked at aligning with our partners. And right now, with the 2 demonstration plants that we have in Calgary, with the project that we're going to have up and running in Mississauga in the first half of next year, and hopefully some of the other ones that we'll have going with other partners like Titan and CEMEX and others, our view is that we're already within touching distance of the variable cost of clinker production. So the cost of goods sold that they currently make limestone-based clinker with, we can be very, very close, if not better than that, at certain scales today with what we know. And that to us is huge, because at that point, if I'm sitting as a plant manager for one of the cement plants in North America or the EU, North America and UK are excellent examples, like the US and the UK, because they have a higher demand than they have supply. And so there's a lot of imports in these markets. And so if you're a plant manager and you're trying to figure out where to install more capacity, our view is that if we have a technology that is decoupling you from fossil fuel use, it's allowing you to sequester a portion of your emissions and use local materials instead of having to import stuff from Indonesia or China or India or Turkey. To us, that is a very compelling value proposition that works at many different levels. And if it can all happen when you're electrifying the production of some of your cement production, yeah, that to us seems like a very compelling argument.
Yeah, this is like a perfect setup to talk next about some of the industry partnerships you were mentioning there. Maybe just to double click though on that supply chain aspect. Can you talk about the supply chain risk that you are able to help mitigate? Because I think in my mind and maybe in many other people's mind, cement is all made in one place. It's rocks. It's really simple, but obviously that is not the case.
Yeah, no, absolutely. And what I would say is increasingly, especially in the last 10 or 15 years, Justin, the supply chains for these big cement companies have become very global. So, as we've shut down coal power plants at record pace in Canada and the US and the EU, a staple cementitious material that these cement companies used to focus on, which was fly ash, has gone away. And so they've had to get that in from countries that still use coal power. Blast furnaces, which are being used to make steel. They make an excellent SCM called blast furnace slag. Again, as Canada has moved away from blast furnaces to electric arc furnaces, Germany and France have done the same thing. That has changed the chemistry of the slag that is produced by these steel plants, and hence essentially entirely decoupled, this byproduct of steel going into cement. So it's had a bizarre effect where as steel production and energy production decarbonizes in a perverse kind of way, it's actually made decarbonizing cement tougher. Right. And now when you add to that some of the stuff that has been happening, not just in the US, I know the US gets a lot of headlines, but Canada, Europe is going to install CBAM. It's already in effect, but its real effects start to come into effect in 2030 and thereafter. When you look at all of these places where they're trying to say we cannot have high carbon or high pollution materials coming into our space, competing with local producers that are being held to a higher standard, like they're trying to close that loophole for heavy industry. And our view is that within that context of people trying to nationalize production, create local supply chains, the argument or the proposition that carbon upcycling offers of using local mine tailings, local steel slags, local ash deposits is very, very strong. Because, if we want to build Canada again, like our prime minister wants us to do, or if we look at what President Trump wants to do with localizing a lot of stuff and getting infrastructure investment back into the US, very different political ideologies, sure, but they both gravitate towards the same rule of saying, build in the US for the US, build in Canada with Canadian equipment, Canadian material, Canadian labor. And so in each of these cases, we're actually seeing this kind of nationalization or this focus on national infrastructure building as being hopefully a very good tailwind for the type of technology and approach that we're taking.
Yeah, no, it makes a lot of sense. And like to not have to ship these materials around the world, there's a cost associated with that. There's carbon emissions, like
environmental liability.
Yeah, it makes a ton of sense from that perspective. I'd love to dive into some of these partnerships that you've established, because you've got a pretty long list of heavy hitters that you've partnered with. You've got partnerships with CEMEX, CRH, Titan. I'd love to understand, and we can maybe talk about the process of getting those partnerships and what clicks, but maybe just at like a macro zoomed out level, like what's been driving the interest from the concrete industry? I think we touched on it a little bit, but there's climate aspects there. But are there other factors that are really putting this on their radar?
Yeah, I would say when it comes to partnerships we have in the cement and concrete space, Justin, I would say the supply chain piece that we just touched on is actually a much more imminent, I think,
Interesting.
factor or risk that they're looking to at least have options around. I wouldn't say that necessarily that they have, absolutely admitted that this is the future. And as you can imagine, with all heavy industry players, they don't look at things in a 4-year cycle. They usually look 10 years and beyond because, when you make a capital investment today and it has a 5, 6, 7-year payback, you're not looking at only crystal ball gazing up to 2029 or the next
Yeah.
presidential or PM cycle or whatnot. So that helps a little bit because they look at risk in a maybe more strategic way than is the case in retail or even, I would argue, in AI and things like that. But what it has helped us do is articulate not only the carbon sequestration angle of our story, which I hope we get to touch on because there is some really interesting work we've done on, where do we see carbon upcycling in 2035 or 2040? But within the context of the cement industry, the fact that they do see these SCMs that they had really gotten used to becoming less and less available and further away is honestly, I think, where they see a lot of tension and risk. And they also see, I think, some of the more aggressive players see an ability to actually carve out a competitive advantage. So they want to take this risk and make it into an opportunity. And I would say for CEMEX, for CRH, for Titan, and frankly, for some of the other companies that we're just beginning to have some active conversations with as well, that's the real, I would say, the difference between what sets them as market leaders and some of their competitors in the space who are maybe still pulling their arms around the risk to kind of figure out what the context is. I think many of these players deserve a lot of credit for looking further ahead. And I just do want to make one quick comment about another strategic that I think deserves a lot of praise in this, who's also on our cap table, which would be Oxy, the oil and gas company from Texas, right? And they're Berkshire Hathaway backed. They have a very long-term vision in kind of how they look at things. They've been a massive supporter of direct air capture and actually acquired Carbon Engineering, which is a massive Canadian success story. Oxy has been our longest strategic partner and investor. I mean, they've been looking at us now ever since our seed round about 3.5 years ago. And, some of the work that we're doing on mineralization of CO2 and trying to figure out how we can really kind of solve these technical challenges in a cost-effective way, even though we don't deal in oil and gas, we don't, have kind of a path to market there at this point, they see us as part of their grand plan. And I think that's been our biggest success generally with strategics is if they have a problem that they look to solve in the next 5 to 10 years that aligns with a value proposition that our tech has, they've generally jumped on board and been, long-term partners for us, not just doing one-offs.
That's such a vote of confidence in what you're building to have, industry leaders like that come on board. And I'm sure great for you to kind of tap into the expertise that they have within their staff as well. Maybe just talk to me a little bit about what do these partnerships mean for carbon upcycling? And I don't know if there's one you maybe want to highlight or focus in on, but yeah, maybe just talk about what does this really unlock when you land a partnership like this? And maybe also what have you found to be key to creating these solid partnerships?
Yeah, I think maybe to answer your second question first, Justin, I would say listening well and understanding what the actual problem is that these guys are grappling with, I think has been a key learning for not just myself, but I would say for all of us in our team. We've grown to about 45 people now. We have colleagues in Germany, in Denmark, in Mexico, in the US. And what we've really found is that overall, if you look at the cement world, it's a world that is quite tight-knit for how global it is. All the major players have a lot of employees that have gone back and forth. A lot of their executive teams, even their boards, have a lot of overlap. And so I think sometimes startups can fall into this trap of really be out there evangelizing instead of actually listening and seeing what the people need. And I think we've become much better at that. We've still got work to do, but I think that's the secret for us, I suppose, the open secret for how these collaborations have started to really become long-term partnerships. The two I'll highlight maybe just very quickly would be the partnership with CRH, who are our partners building our first full-scale carbon capture and utilization plant in Mississauga, which we expect to have up and running by this time next year. That is a huge step for us. And, I cannot speak highly enough of the CRH organization. They've been pioneers in some of the excellent acquisition work that they've done. They've been very disciplined stewards of capital. Within a Canadian context, a comparison I've heard is the way Murray Edwards and CNRL run that tight ship is very similar to how CRH works in the cement world. So they're very disciplined. They drive sharp pencils in every transaction that they do. And on top of that, they are calculated risk takers. So the fact that they've committed to a full-scale CCU plant for us in Mississauga, we've been able to get that project as far as we have with them, with literally crews on the ground today as we speak and, putting the foundations in. I mean, that kind of stuff is massively exciting for us. And I would say Titan, on the back of that, has been another group that has a very strong history of innovating and getting new solutions into the cement world. They're a slightly smaller player than the CRHs, the Holcim's, the Heidelbergs of the world, but they've also been able to really leverage some of the technical learnings that they've had in-house with this collaborative attitude that they have of reaching out to small companies and engaging with them early. And over the last year and a half, in both of these cases, we've been able to really kind of drive forward a very action-oriented plan and drive towards getting projects in the ground. Because I think ultimately what we will gauge our success on come 2030 is how many thousands and millions of tons have we delivered to clients that have had a lower carbon footprint than what they would have used before. So, for us, it's pretty easy to track that. You can't deny once that stuff is left, and you can't make it up if it hasn't happened, right? So I think for us, we need partners that believe in us, help us accelerate the trajectory of the adoption of our tech. And candidly, from a personal perspective, I found it really gratifying over the last year and a half to see some of the relationships that we've built with people that are driving this work. And, I could list off 50 names for you of people that we've really gotten to know really well and deeply connected with. And I think hopefully that continues to go in force over the next few years as well.
Absolutely. Yeah, no, it really takes a village to make these things viable and get off the ground. So you're talking about 2030. What needs to happen to scale this further? Because right now we're talking about, maybe a couple tens of thousands of tons. We've talked about the scale of the global concrete industry. What are some of the missing pieces that you would love to see come into play to really scale adoption for low carbon concrete?
Yeah, and I speak almost on behalf of the industry here when I say this. I would say there are two pieces, Justin, that have to come together. And I genuinely believe that Canada is well positioned to be able to answer on both these fronts. I think one piece is procurement and North Star setting. I think if we're going to build Canada or the US or whatever other economy that's going to build AI infrastructure or power infrastructure and kind of develop some of these remote communities, we have to focus on giving industry a steady direction and saying, we're going to build better, we're going to build stronger, and we're going to build with local resources, local content, whether it be labor or materials or technology. And I think direction setting in that way, which I think comes through procurement, is a huge part. And I think the second one is financing, because I think what we've generally found, you look at how renewables worked really well, the adoption of solar and wind in the early 2000s. I mean, the US government at the time came up with some really good incentives, and they were able to kind of drag these incentives out at a timescale of about a decade, right? And that was enough for private investors, private capital allocators to say, we're going to build with these assumptions. And as long as this thing can pay itself back in 7 years or 6 years or 5 years, and of course, what we all got pleasantly surprised by was how quickly the cost curve of solar and wind came down in that time, right? So they were initially able to underwrite these projects with a certainty of policy and finance in the first 10 years. And I think that's all we need to do for cement and concrete as well. My view is that if there were steady standards around procurement and some financing mechanisms to help capital providers get comfortable with the first of a kind or second of a kind risk on projects, yes, we do have to build a few 30 or 60 or 100,000 ton a year projects at Carbon Upcycling for all of our partners to feel sufficiently comfortable with the state of the technology. This is also where the financing has to be really important, because it cannot all come in from venture capital folks. It cannot come in from growth investors. We look at an instrument like the Canada Growth Fund as an example, which is an excellent innovation in this way. And, the US LPO program in the States, the Loan Programs Office, is another one, right? Which is helping these companies get past this valley of death. And our view is that that's the kind of stuff that needs to happen. Europe has got its own instrument with the European Investment Bank. These type of things have to be absolutely reinforced to the hilt. And especially in the backdrop of what you saw with Northvolt and what you've seen with some of these renewable companies kind of struggle. The EV sector is struggling at the moment. If we do not show with policy and frankly some inspirational goal setting that this is a course that we're going to stay on for at least the next 10 years, I think that we've got bigger problems than just, how does carbon
Yeah.
upcycling become successful? But I believe even with everything we've done right from a technical perspective, from an economic standpoint, these kind of levers are still massively critical to making sure that we can
Yes.
leverage this into impact on the ground. And without policy and without some ambitious financing kind of structures, there's
Yeah.
a fundamental risk that it may not happen.
Yeah, no, those make a lot of sense as key levers. And there's a lot of talk right now about major infrastructure projects, all of which will require huge amounts of concrete and cement to get off the ground. I think there's a huge opportunity there for governments to be committing, some percentage even of that concrete should be low carbon. And you can expand that too to like building materials generally. Some portion of that could be creating that demand pull for creating a market. Because I think there's only so much you can do with push. And at some point, I think you have to pull. Like we can put money in incentives and all this kind of stuff, but create demand, make the financing better for the projects that actually are building this stuff. I think those are two great levers to be pulling.
Yeah, you just got me thinking there. And I just wanted to add, on top of that pull piece, which I absolutely agree with, I think the government also needs to let industry guide the way. And I think that's one of the things that we can really learn from the last 4 years, both in Canada and the US, candidly, is that there's been a pendulum swing where either the policy has been too pro-industry and almost kind of not willing to make any changes, or it's been too anti-industry and said, well, we got to go with moonshots because the guys in the industry aren't going to change. Both of those, I think, are quite cynical in their own ways. Like what really needs to happen is people need to take a pragmatic approach and say, you know what? If you want to figure out the pathway to cement decarbonization and making, let's say North American cement more locally sourced and independent from international kind of risks, the best people to answer how to do that within a time frame that you set, whether it's 5 years, 10 years, or 20 years, is probably the industry that lives and breathes in that market. And so, you shouldn't be goal setting and kind of doing this from a policy think tank void of some of this input. And then you need to, put them in this uncomfortable space. Like I'm a parent, I've got 2 kids, and like you want your kid to be, have everything they want and all this stuff. But like
Right.
you also want to stretch them and you also want to push them so that they become better and grow. And, ultimately you can't always be helicoptering over them so that in high school or college they succeed regardless of how terrible they are at stuff. Like you want them to actually grow their own muscles. You want them to grow their own mind. And that's, I think, what we need to do is take that constructive, collaborative approach and be very pragmatic about what we can do. Just because we think that something, is fundamentally required, but, there's no industry buy-in for it, I don't think it's government's place to force that down on people. But it is in their mandate to make that more attainable over time through some deliberate practices. And I think the what is just as important as the how. And I think we've just been oscillating so much between that.
That's really interesting. Yeah. And I mean, we're at such an interesting time in Canada where there's this huge focus on these nation building projects, economic security, economic growth, rebuilding domestic manufacturing. I mean, I feel like carbon upcycling is really at the epicenter of all of those issues. But I think that really speaks to maybe a need for more industrial policy. You were talking about kind of the difference between the what and the how. And I think the what has kind of been left out in the policy conversation. I think there's been a bit more of a focus on the how over the past like 10 years or so. But I think this is an interesting space where we could say, this is where we're going. This is what we want to accomplish. This is what a new industry looks like in Canada that is focused on clean growth, low carbon, et cetera, this kind of new paradigm. But how we get there, maybe that's where the industry needs to lead, the partnerships need to lead, the carbon upcycling need to lead and kind of drive it forward. But I think some signals around what do we need to accomplish, where do we need to go would be really beneficial.
I completely agree. And I think we're in such an exciting moment in time because, like you said, the new government has already made this mandate about nation building projects. And, you look at the cement plant in Mississauga as an example that we're working on. It's a very interesting tidbit of history. That plant was built about 5 years after the Second World War was finished. And so the story is that a lot of the Canadian veterans that came back from that second war then had to find jobs. And many of them worked on this plant because when you start building out a country of Canada at the time, which was about 12, 15 million people, you need homes for these people. And a lot of these boomers had to come back and start building their families and stuff. So,
Right.
I mean, in a very, very bizarre way, history is kind of turning where now we have a prime minister who says we're going to build nation building projects, the likes of which we haven't built since the Second World War. And that plant is having its 75th anniversary next year. That's when our plant will be up and running there. And
Wow.
in a sense, like we see this as a blueprint of what needs to happen across the country. We have 16 other cement plants in Canada. We have hundreds of mining sites. We have tens of sites that are producing steel with slag and things like that that we could use. And our view is that if the story is that we want to get to 2030 and create a Canadian-made, Canadian-sourced product for use in building Canada up as a nation, I mean, how much more compelling can that get? And tell me one taxpayer that would be upset about that versus buying cement from, I don't know, Turkey, right? Like if they are, then I mean, I'd just be curious why. But I mean,
Right.
as someone who's been in this country now for 14 years, I mean, I just think that would be something we'd be very proud to get behind.
Yeah, for sure. I think it takes some institutional muscle building where that has not been the practice for a while, and now there's this kind of shift back. And I think everyone along the supply chain is going to need to recalibrate a little bit to kind of adjust to the new reality. But it's where we have to go. And I'll link to this in the show notes, but you wrote a really great op-ed on this topic, exactly what is needed to kind of seize this moment and build out domestic manufacturing. And one of the things you pointed out there was kind of that value add step, and that Canada has been exporting raw materials without doing a lot of processing for the most part. That's a huge economic opportunity. Doing that, upgrading that processing, the upcycling that you're doing to actually create value-added products here rather than somewhere else and then re-importing them.
Yeah, I mean, obviously you're kind of quoting what I said in the op-ed there, and I feel very strongly about that, Justin. And I think really what it needs is vision and ambition. And thus far, I mean, there's been a big disconnect between heavy industry in Canada and policy and the general mass of people. Like most normal people do not see direct benefits from the energy sector that we have in Canada, or the steel sector, or the aluminum sector. And that disconnect can be bridged if we start going with this ambition and saying, you know what, like we're going to build the world's greatest nation and we're going to use our own resources to do it. It's not just something we're going to talk about in rhetoric, but these are the kind of policies and structure we're going to provide to make that happen. And I absolutely believe that, you know, this is a great opportunity for us to get ahead.
Yeah. And you talked about the carbon border adjustments happening, and we need to be looking ahead at like, where is the world going, and building those industries and not the industries from 50 years ago or whatever it may be. So the last thing I'd love to hear about, you recently closed a fundraising round in what is one of the most challenging markets in a very long time. Could you tell me a little bit about the raise, what that means for the company, and what that experience was like? How have investor perspectives shifted over the past couple of years?
Yeah, Justin. So firstly, thank you. You're exactly right. We just closed an investment round led by Builders Vision, which is Lucas Walton's kind of family office. And that's the family that was essentially stemming from the success they had at Walmart. Lucas in particular is an excellent thought leader, a visionary, and his team with James Lindsay and Andrew Yee have essentially led this investment round in carbon upcycling to make a bet in low carbon cement. And honestly, I think their investment thesis, which very much aligns with kind of our view on the space, is that if we're going to make drastic emission reductions and create sustainability trends in this space over the next 10 years, they have to be driven by a mix of practical technologies that can be adopted quickly, but also cost effectively without requiring a green premium. And I think those were the two boxes we had to convince them that we could tick. They obviously talked a lot to our strategic partners, companies like the ones we've talked about here. And we were able to get them across the line to say, this is exactly the type of thing that they believe has the legs to make an impact and go forward till when the tide turns inevitably again. And, you know, we're in a market where carbon does matter again. And more importantly, domestic supply chains continue to be as important as they are today. So yeah, very fortunate to have this. You know, to your comment from earlier, we've been very lucky just generally to have very strong investors behind us. We have the Business Development Bank of Canada, BDC. We have Climate Investments from London. We have Oxy, as I mentioned earlier. We have CRH, CEMEX, Titan. We have Amplify Capital, which is an impact investor. And we've also been able to expand our board with not just people like Clean Energy Ventures that led our seed round from the US, but also people like Steven Birkenfeld, who also serves on another Canadian success story, Savante. He's the
Nice.
chair of their board and ours. And so very, very fortunate to have people like that on board. And I mean, overall, I would say the big difference we've seen in the market is cost efficiency and a path to projects and profitability is significantly more real than it was even a year ago, and definitely more than 2 years ago. And so the fact that we've always been very practical and we haven't just changed our tune on this, I think has really resonated. And with this, hopefully we're in a really solid position to keep executing and start adding more zeros to the amount of cementitious material we get out into the field.
That's fantastic. I mean, you really do have some really strong partners on your cap table. It sounds like it makes a lot of sense to hear this focus on the fundamentals and having a line of sight to profitability. So I think it's a bit of a correction that I think is maybe a little more challenging for some folks, but it seems like a good fit for you.
Yeah, definitely not as much of a sucker punch, I suppose, for us as it has been for others. But yeah. It's still been challenging. And I think to continue to build a syndicate of supporters like the ones we have now with builders joining our team is massively gratifying.
Awesome. Well, we're pretty much at the end of our time here. I want to end with a quick rapid fire for you. So you don't need to put too much thought into this, but what would be your word of advice for founders starting their own venture or maybe at that seed stage, looking to make the leap up? And particularly, maybe you could talk about picking partners or investors.
Yeah, I think two pieces of advice. I think one will be something we touched on earlier, Justin, which is just listen to your customer, really understand their problem. And I do genuinely think that, this whole notion that we've been kind of romanticizing about, like the startup is always an outsider and, brings in a new perspective and all that. Yes, but I think we've overplayed that. You also need to have some deep industry understanding of what you're actually solving, or else you might be solving the wrong problem. And I think the second thing with regards to picking investors in particular, I would say make sure that they're also good listeners and that they also understand what they're investing in. Because sometimes I really don't envy VCs sometimes because, they have to be experts at so many different things. But ultimately, if you feel in your gut that they haven't quite understood your theory of change and what type of thesis your company is operating around, even if the money's on the table, I would say strongly think about taking it, because it might seem like you're aligned in this moment in time, but usually venture capital funds have to return their capital in 5, 7, 8 years. You have to look that far out and say, are we still going to be aligned then? Or, am I writing my own kind of ticket out of the company kind of thing?
Right. Yeah, no, that's such a good point. If there's a 10-year timeline on a fund and they're at year 6, you need to ask some questions around, are we going to meet the milestones that they're expecting in that 6-year period? Or what are your expectations at that 6-year mark? It's probably not an exit, but maybe it's something else. And it sounds like kind of having that clarity with them on what are the expectations is a really key part of that.
Yeah, absolutely. I mean, you said it really well there. Yeah.
The second question, a lighter one. What's a book that you would recommend to folks?
I read a lot. There is a really interesting one I'm reading right now. It's called Polymath. It talks about polymaths across generations and how it is the human condition to not be specialized in anything. And we keep trying to suppress that by over specializing and calling people by their title or whatnot. And yeah, I found that to be a really good book, but I'm usually reading like 5 or 6 books at a time. So it's
nice.
Kind of hard for me to pick out any specific one.
Yeah, for sure. And then what's maybe like one big lesson that you've learned being a CEO and a father at the same time?
Yeah, it's like I told you I have 2 kids. I feel Carbon Upcycling is my third, and I feel the most demanding. So I think maybe the biggest parallels are just that I didn't have any formal leadership experience before the company, and I did have a startup before Carbon Upcycling, which never quite grew in the same way. And I kind of stepped away from it relatively early. So kind of learning on the job how to lead people, how to manage. Yeah, I think there's a huge amount of parallels in professional leadership and in parenting. So I would say that's probably the biggest lesson, is that in a sense, I'm actually, when I get enough sleep, I'm quite grateful that I'm doing both at the same time, because I can kind of take lessons from one to the other. But yeah, that's probably as deep as I can get at this point.
For sure. Yeah. Awesome. Well, Apoorv, thanks so much for spending some time with us. I honestly think we could have done like another hour very easily.
We can do another one once Mississauga's up and running.
Yes, let's do it. Maybe we can set up a site visit or something. That'd be a lot of fun.
I was just going to say, we can do it on site, and yeah, you can get to see what we're working on.
That sounds great. Yeah, thanks so much for your time. Really appreciate it.
Likewise, Justin. Thank you.
Thanks for joining us. If you enjoyed today's episode, leave a rating and a review on Spotify or Apple Podcasts. It would mean a lot and helps grow the show. To stay in the loop on Canadian climate tech news, recent fundraising, job postings, events, and more, subscribe to the Climate Tech Canada newsletter on our website. Thanks for listening. We'll see you next time.